Oh, wait, you're listening?
Okay.
All right.
Okay.
All right.
You're
Listening
to Radiolab.
Radiolab.
From
WNYC.
See?
Yeah.
This is Radiolab. I'm Molly Webster. I'm going to open up the show today with deep sea explorer and oceanographer Edie Widder.
I'm still here, ready to go.
Why don't you tell me how you bumped into our friend?
Our friend, the giant squid?
No, our friend, the anglerfish.
Oh, the anglerfish.
I'm here for the smaller
Got you.
angler. I called Edie because I wanted to talk to her about anglerfish and this kind of weird thing I had heard about their immune systems and how they mate with each other.
Wanted to be, but never.
But then Edie wooed me with a story that had to do with none of that, about being a grad student in the 80s, working on the back of a boat and pulling sea creatures out of the deep.
I was going to sea on ships with scientists who had developed a way to bring animals up from the deep sea alive. So they usually come up dead when you bring them up in the net because of temperature changes. They're basically cooked alive.
Oh, wow.
So he had developed what was called a thermally insulated closing cod end that went on the end of a net. And so you'd bring them up and they'd still be alive. So, you know, they'd be swirling around in that tub and you'd have to plunge your hand into this icy cold water and your hand would go to completely numb. And one of the first animals I pulled out was this bright red shrimp about the size of a hamster. And it was squirting neon blue light out of tubes on either side of its mouth. And it pooled in my hand and then dripped between my fingers back into the tub.
Really?
It was astonishing.
What was it like to hold dripping light?
I can't describe it any other way. I mean, it was cold light and it was brilliantly blue. If you're fully dark adapted, bioluminescence can look very bright. And it went on glowing in the water and then kind of swirled around and disappeared.
Wow, I can't even, because I guess I always think of light or something that creates light as like in a container, you know, like almost like a light bulb has a border. I never think of it as like oozy.
Oh, for me, it was revelatory. I just couldn't believe that all of this existed. And, you know, at that time, you could pick up a marine biology textbook and find no mention of bioluminescence.
No way. Oh, really?
Yes. It's not that they didn't know about it. It just didn't think it was very important.
After that experience, Edie spent the next 40 years, and counting because she's still going, chasing the light, diving into the ocean over and over and over again in search of creatures that glowed like the shrimp. How many times have you gone down 3,000 feet in the ocean?
I stopped counting after about 300.
300?
I'm in the hundreds, definitely.
Wow.
Oh, yeah, so many things I've seen from submersibles that I'm pretty sure nobody's ever seen.
Edie has plunged into the unknown in a way that few people on the planet ever have. And so I very quickly abandoned my sort of anglerfish interest, and I just followed her into the deep, into a world of brilliance and color where light suddenly comes to life.
My first open ocean dive was in the Santa Barbara Channel. I was testing this diving suit called WASP that was developed by the offshore oil industry for diving on oil rigs down to 2,000 feet.
Is it like you're in like an astronaut suit that you can like control?
Yeah, it's exactly like an astronaut suit. It's got a plexiglass bubble for the head, Michelin man arms, no legs for walking on the bottom, just a pod with thrusters that are attached to it, and you control the thrusters with foot switches on the bottom of the suit. It's like being in a fishbowl, but the fish are on the outside and the people are on the inside.
You're the fish.
Yep.
Wait, your first like big dive was in this like Marshmallow Man suit?
Yep. But that first dive was just to be to 800 feet to make sure I wasn't going to have a claustrophobic meltdown.
Oh my God, you are so gutsy. Did you get nervous?
Yeah.
Okay.
I was nervous. It was an early evening dive, and they lowered me off the back of the ship. And
I'm just imagining kind of an ungainly splash when you hit the water.
Yeah, that's about right. And they got down to 800 feet, and I turned out the lights. And I was instantly in the center of this fireworks display. And I was just blown away by how much light there was all around me. Just sparkles and glows and squirts.
Squirts?
Squirts. All of it, different shades of brilliant, brilliant blue.
Oh, blue.
All blue.
Oh, I was imagining yellow.
No, blue is the color that travels farthest through seawater, and so most of it by far is blue.
And is it pointillistic glowing? Like, is it dots, or is it like
some of it's
long
dots,
streaming things?
Some of it's like a little smoke cloud, or it can be a little cloud of particles.
That's so cute.
The weirdest thing for me, though, was that when I turned on the lights, there was almost nothing in the water column that I could identify as a potential source for all this luminescence that I was seeing. But you couldn't see it with the lights on.
You have to turn the lights off to actually see what you want to see.
Right.
And could it all have been the same thing, or do you think it was many different things?
That first dive, it was many different things, but I was just overwhelmed by how much luminescence there was. And my brain was racing as they pulled me up, because I just thought, this is so important, but how the hell do you study it if you turn on the lights and there's nothing there?
And why did you think it was so important?
Because it takes so much energy to produce light, to use that much energy, so critical to life, that, there's no question this had to be about life or death. There have been experiments that have been done that have found, for example, if you starve bioluminescent copepods, they will give up the ability to make eggs before they give up the ability to make light.
Wow.
Because they use their light for defense in that particular case. And so they can't live without their bioluminescence.
Wait, tell me about the different ways these animals use bioluminescence.
So one way is to find food. So a lot of them have, like fish and squid and shrimp, that have built-in light organs next to their eyes that they use like flashlights to be able to see in the dark. There are animals that have oddly shaped light organs that allow the male to find this female of his species to mate with, so to attract a mate. There's animals that will use every light organ they've got, which may have many different functions, but they'll flash like crazy if they're caught in the clutches of a predator, because their luminescence is functioning as what's known as a bioluminescent burglar alarm. It's meant to attract the attention of larger predators that may attack their attacker and therefore afford them an opportunity for escape. Mm-hmm. And then there is a huge amount of it that's used for camouflage, something that's called counter-illumination. A lot of them will produce bioluminescence from their bellies that exactly matches the color and intensity of sunlight filtering down from above to camouflage their silhouette. And if a cloud goes over the sun and dims the sunlight, they dim their bioluminescence.
That quickly? They can respond that quickly?
Absolutely. The cookie cutter shark, which is one of my favorites, produces bioluminescence from its belly. That's the most perfect counter-illumination pattern you've ever seen, because it's the light organs are so small that it just completely disappears. It's the perfect cloaking device.
But like, if the sun is passing over and then a cloud passes over the sun, like, how does it sense like the right amount of light shift that must occur and then quickly adapt it?
Well, that's
like, how can it read the light?
That is an excellent question. So some of them actually have a light organ above their eye that they can see. They can see that light organ relative to the background light to be able to adjust to exactly match. Some of the others, we're not sure how they do it because they don't seem to have a sensor system, a feedback like that.
Edie just kept going back again and again to how much we don't know about the deep sea, like how light is used, how light is made. And then she had so many cool, weird stories about like these convoluted, almost gothic light organs.
There is one type of anglerfish known as the bearded sea devil.
Okay.
It's got a luminescent lure on its forehead to attract food, the way most anglerfish do, but it's got a chin barbel on its chin. And the absolutely insane thing about this is not only that it's got these two completely different light organs on its head, but the one coming out of its chin is intrinsic chemistry, luciferin and luciferase. But the one coming up out of its forehead is bioluminescent bacteria.
The anglerfish literally has kind of a bobble that comes out over its forehead and has bioluminescent bacteria tucked inside of it.
Right.
Where does the bacteria come from? Like, does it find the fish early in life, or is it like birthed with the fish?
Well, a lot of these bioluminescent bacteria are available in ocean water. And so it's thought that they pick the bacteria up from the environment. But the weird thing about bioluminescent bacteria is bacteria glow all the time because their light output is linked to their what is basically their breathing, their respiratory chain. So as long as they've got enough oxygen, they just go on glowing. So some of these anglerfish control the light output by just controlling the amount of oxygen. I mean, it's different in different fish. Some of them do it by having a mechanical shutter that just covers the light organ.
Almost like an eyelid?
Yes, there's some flashlight fish that have an eyelid that closes up over the light organ to be able to block out the glowing bacteria. There's others that roll the whole light organ back into their head, like the headlights on your Lamborghini.
What?
Yep.
I just think of light as like so passive in a way. Like the fact that it's so active and alive feeling.
That's exactly right. I've always taken bioluminescence as an indicator of life. And I think it's got a lot to tell us about life in the ocean.
Like what?
Where it is.
Yes.
How the carbon pump is functioning. But even more than that, it feels like almost the idea of having another eye on my body that is searching around and reading the environment and then changing what I look like to match that environment. It feels like super intelligence. It's super evolution.
We'll be back in just a minute.
I have one answer for a question you didn't ask.
Ooh. Oh, please tell me. I love those.
Is how did bioluminescent bacteria come to be?
Oh, my God. This is Radiolab. I'm Molly, and we are back with Edie.
Because this was a hotly contested topic when I was a graduate student, because the conundrum was that a single bacterium does not produce enough light to be seen by any known organism. So how could there be a selective advantage to producing light? How could it ever be selected for? Mm-hmm. Well, there were some experiments done a few years back by some Polish scientists where they had light-producing bioluminescent bacteria and a dark strain, and they mixed them together, and when they grew them in a dish, the dark strain always overgrew the light strain because it takes energy to produce bioluminescence. So further questions about, what could possibly be the selective advantage when it's energetically costly to produce light. But if they irradiated that dish then with UV light, then suddenly the thing flipped, and now the light-producing cells had the advantage, and they overran the dish. And it turned out the reason was an enzyme called photolyase that repairs DNA damage from UV light, which happens in the upper ocean. And so the light produced by a single dinoflagellate was enough to activate this light-activated enzyme called photolyase. And so the selective advantage had nothing to do with vision initially. It had to do with protection against UV light.
So hundreds of millions of years ago, there were these tiny cells out in the ocean, and they glowed. And even though no one could see it, it made a difference because it let them heal their DNA that was damaged by the sun. But as these creatures went deeper and deeper into the ocean, the sun started mattering less, and the glow started mattering more. They could use it to lure and to lie, to hunt or mate or survive. And it's into this world that Edie goes, basically just to observe and study it, until one day, almost by accident, she becomes a part of it.
In 1985, I got to pilot a single-person submersible called Deep Rover. And what I discovered with that, which was a major breakthrough in understanding the nature of the visual environment in the deep sea, was if I trimmed the sub out to neutral buoyancy and just made it as dark as I possibly could. I had black tape, so I blackened out any little indicator lights. And I waited, and I waited, and I waited. Nothing. Just as black you can imagine. But if I activated the thrusters, there would be these vortices of light swirling up out of the thrusters and particles streaming back over the sphere and just light all around me. With later dives, I discovered that I could also stimulate it by turning the lights on and off. I think it was probably one of the pilots that alerted me to it originally, where you just flick the lights on and off, and everything surrounding you seems to come on in unison and then fade out in unison. It's a phenomenon we call the flashback phenomenon.
And how long is the flash that you put out?
It'd be on, off, and on the second flash, you are surrounded by all of these things lighting up. We actually don't know what is flashing back at us, which makes it even more intriguing. But I think what I'm seeing with the flashback is bioluminescence in marine snow. Marine snow are all of these particulate organic matter that filters down through the ocean and is the base of the food web in the deep ocean. So plankton photosynthesizing at the surface die, and as they sink through the ocean, they often are described as looking like marine snow, these flocculent white particles. And some marine snow is bioluminescent. Mm-hmm. And it seems to be bioluminescent because of bacteria. And so when you bump the particle, you're introducing oxygen into the marine snow environment, and you create light.
I see.
I think the reason that the light stimulus works is because there are cyanobacteria also in marine snow, and you're activating photosynthesis, which produces oxygen.
And do you think it's all marine snow that's doing the flashback, or are there other creatures that are also doing it?
It's mostly the marine snow. We would occasionally see something identifiable like a tomopterid worm. That was particularly recognizable because it's yellow. Almost looks like gold. It's so beautiful.
Edie doesn't know for sure what's happening, but she thinks that the flashback is a natural phenomenon, that it's actually something that's happening between the deep sea creatures when she's not there. So a fin brushes the water and mixes in oxygen, and it gets bacteria to light up. Or a light on a fish's belly flashes and it makes photosynthesis happen, and again, the world comes alive. And Edie believes that this back and forth with light is not accidental, but that it's purposeful.
The bacteria glow in order to be eaten. They want to be eaten, excuse the anthropomorphism, but it is to their advantage to be eaten because then they are reintroduced into the food-rich environment of a fish gut.
And that when she does that flashback with the creatures in the deep sea, in a sense, she's become one of them. So her submarine thruster is like a fin, or her flashlight is like a lure. And in those moments, she's become part of the dance.
It's just such a remarkable feeling. Not a poet, but there's no question I feel a tremendous sense of awe. Very often the feeling of, I want to stay here. I want to understand this. I mean, that's key to who we are as human beings is, we were born as strangers in a strange land. We don't know anything when we're born, and our survival on the planet has been to explore the world around us and share that information. And I think that there's something very innate in us that responds to that. And the others that I have shared it with have had the same experience.
I don't have a ton of experience with bioluminescence, but one story always sticks with me, which is, and I've never seen this happen before, but I grew up in a kind of rural Ohio, in farm country, and we had a pond, and my parents sold the property that we grew up on, and my very last night at the property, I went out for a walk at night. Like, I loved walking around in like the woods and listening to night creatures and stuff. And so I went for a walk, and I walked down to the edge of the pond, and the whole edge where the water met the soil was all lit up.
Glowing?
And yeah, it was like all bioluminescing. And
that had to be bacteria.
And like, where would it suddenly come from?
Well, something organic in the water, but it's surprising. You don't see that very often. Wow, that's an interesting story, actually.
It was so beautiful, and I actually went back inside and woke my parents up, and we all marched down to the pond and just stood there and like looked at this glowing.
See, now there's a mystery that needs to be solved. I can't tell you for sure what that was, but
it's so powerful.
I think it's interesting that people that have had interactions with bioluminescence often rank them as their most meaningful lifetime experiences that they carry with them throughout their lives. It's interacting with life. It's life illuminated. And there's this interactivity to it where you're making things happen. You're in a bioluminescent bay, and you run your hand outside your kayak, and off of every fingertip, you've got sparkles. It's like being Merlin.
Yeah, there is like a deep communicate. It almost feels like you're like saying something to each other.
Yeah.
That
it's a form of communication. I've somewhat provocatively tried to claim several times that it may be the most common form of communication on the planet. Partly depends on how you define communication.
And what do you think you're communicating, and what do you think it is communicating back to you?
I'm most focused on what it's communicating back to me. I have no idea.
Okay.
Actually, there have been a few times when I've communicated with luminescent animals, and in one case, there were some deep sea shrimp that I was getting a great response out of, and I had no idea what I was saying, but I was pretty sure it was something sexy.
Why?
Because that was the kind of response you'd expect from a crustacean that was responding to a
titillated.
Yeah, it was putting out a string of dots in the water.
A string of glowing dots,
glowing pearls. Yeah,
and that's what it does when it's like turned on. When it's like, "Hey, come hither."
Yeah.
So you do believe that there's like some sort of messaging in the light, like that.
Oh, there can be, yes, and definitely some of these animals have pretty elaborate displays, and I think they're communicating something important, but we have done so little actual observing that most of it's guesswork.
And so when you're like down there flashing, you're like, I'm going to flash 3 times, and I don't know if in shrimp language that means something. We'll just see what happens.
Yep. Best job in the world.
This episode was produced by Maria Paz Gutiérrez with original reporting and production help from me, Molly Webster. I want to thank Dr. Edie Widder, who is the CEO and senior scientist at the Ocean Research and Conservation Association. If you're interested in seeing more of Edie's work, it just so happens that there is a documentary that is soon to drop about her. It's currently making the rounds at festivals. It is called A Life Illuminated. It's by our friends over at Sandbox Films and director Tasha Van Zandt. And Edie says it has some of the best underwater footage of bioluminescence ever recorded. But you know what? If you're too impatient to wait for that documentary, if you just want to go see it all...
You can totally do that, you know.
Wait, how?
Oh, there's commercial operations.
Like, how deep do they go?
2,000 feet.
Are these going to cost me like $50,000?
That might be right. Yeah, something like that.
Yeah, okay. Well, I'll work on that public radio team.
Good luck.
If you are interested in more deep sea stuff, Radiolab has got the content for you. I would say go check out Octomom, which is about an octopus and her brood of eggs. It also happens to feature a diving buddy of Edie's. And then we also produce something called The Darkest Dark, which is about darkness. And it features a former mentee, now colleague of Edie. Because apparently nothing happens in the deep sea that Edie Widder doesn't know about. I don't actually know if that's true. But for now, I will just say thank you so much for listening. This is Radiolab. I'm Molly Webster. Goodbye.
Hi, I'm Basit Kari and I'm from Somerset, New Jersey, and here are the staff credits. Radiolab is hosted by Lulu Miller and Latif Nasser. Soren Wheeler is our executive editor. Sarah Sandback is our executive director. And our managing editor is Pat Walters. Dylan Keefe is our director of sound design. Our staff includes Simon Adler, Jeremy Bloom, W. Harry Fortuna, David Gable, Maria Paz Gutierrez, Sindhu Niasambandam, Matt Keelty, Mona Madgavkar, Annie McEwen, Alex Neeson, Sarah Kari, Anissa Vitsa, Ariane Wack, Molly Webster, and Jessica Young, with help from Rebecca Rand. Our fact checkers are Diane Kelly, Emily Krieger, Anna Pujol Mazzini, and Natalie Middleton.
Hi, I'm Maddie, and I'm from Frederick, Maryland. Leadership support for Radiolab's science programming is provided by the Simmons Foundation and the John Templeton Foundation. Foundational support for Radiolab was provided by the Alfred P. Sloan Foundation.